Everyone for joining in and welcome back. So just give me a minute. Let me share my screen. All right. Okay. So welcome back. Today we are going to talk about fine tuning LLMs. So before getting into fine tuning LLMs, let's have a brief recap of what we did last week. So last week we started with the large language models fundamentals. We spoke about what large language models are, what neural networks are, and some of the common neural network architectures. And then we went into transformers. So we saw the shortcomings of RNN, where RNNs have limited contextual awareness and they have difficulty processing long range dependencies. And that's what was resolved using the transformer architecture. So if you see the attention is all you need paper basically introduced three main concepts of positional encoding, attention, and self attention. And then we saw the encoder and the decoder architecture of the transformers, where encoder architecture is more around understanding of the text, and it is used for auto encoding models, where a common example would be classification type of tasks. And then we saw the decoder architecture, which is used for auto regressive models, and it is mainly used for generation of the text. So we saw autoregressive models, example is GPT, autoencoding models such as BERT. And then we went into how LLMs work, and we learned some key terminologies such as pre-training. So I'll just give a brief, like one or two liners of on these terminologies, and then we'll dive into fine tuning. So, what is pre-training? Pre-training is a phase where the language model is trained on a very large data set, and this data is usually scraped from the internet. And this is the phase where the model learns the general concept of the language, uh, the grammar, and the basic skills of the language. Then we saw transfer learning. So transfer learning is basically whatever the model has learned in the pre-training phase, we are applying that learning onto the downstream tasks. And then we spoke about fine tuning. So fine tuning is basically training those model on a smaller data set and on a very task specific data. So we will dive deep into these stages in the collab in a bit. Then we spoke about tokenization. So tokenization is basically taking the input and converting that input into the vector. Tokens can be words, punctuations, individual characters, or subwords. And then we spoke about embeddings. So embedding is just mathematical representation of words, and it adds additional information to the input, such as positional embedding, which adds the position of the words. And then there is something called a segment embedding, which if you have sentences, it basically adds the sentence sequence to the input. Right. So now let's dive into fine tuning large language models. Okay. So what we are going to do in today's session is we are going to start with a collab. Let me open my collab. Okay. So what are we doing here in the collab is we will look at a we will do a comparison of how the output looks like from a pre-trained model versus from a fine-tuned model, and then we are going to uh, do an instruction fine-tuning on a company's data set, and we look into the steps of data processing, training, and evaluation. Okay, so let's get started. I'm using. I'll start with the libraries or modules which we are using in this Colab. So I have installed Pandas and JSON lines. JSON lines, you'll see in a bit why we are using JSON lines. And then we are using Lamini library. So Lamini provides us Llama 2 base model which we can run on CPU over here. So we are going to use the Llama 2 model from the Slamini library. And let's get started. So what I'm doing over here is I am loading the base runner from the Llama module, which is coming from the Lamini library, which we are using. And we are using this Llama 2 model, which has been trained on 7 billion parameters. And this model, you can find it on Hugging Face as well. Now, this is a pre-trained model, and we are giving this input to this model. Tell me how to train my dog to sit. And this is the output from the pre-trained model, where it says, oh, just let me go here. Yeah. Tell me, the output of this is tell me how to train my dog to sit. I have a 10-month-old puppy and I want to train him to sit. I have tried the treat method and he just sits there and looks at me like I'm crazy. So if you see this output, this is very basic text which it has generated. And if you go till the end, it starts repeating itself. So if you look at it over here, I have tried the sit command and he just looks at me like crazy. I've tried the sit command and he just looks at me like crazy. So it is just blabbering. It doesn't make much sense. But as we can see, it is still relevant to what we have inputted over here. So whatever prompt we have given, the text is still relevant to that prompt, but it doesn't make much of a sense. So now let's look at how a fine-tuned model, fine output of a fine-tuned model would look like. So we are using Llama 2 model over here, Llama 2, which is trained on 7 billion parameters and which is being fine-tuned for a chat interface. So if we give this prompt to this model, you see the output is very structured, and it gives you a step-by-step guide on how to train your dog to uh, sit on command, and then it gives you like 5 steps over here. So this is what fine tuning does. It gives you very specific answers. It gives you information specific to what you are asking that model. Okay. Uh, so next we'll dive into where fine tuning fits in. So here what we are going to do is we are going to look at how uh, so the first step is pre-training, right? So let's just look at what kind of data are we using in the pre-training step, and why is the model generating very random text during the pre-training, and then enter into fine-tuning. So here what we are doing is we are using this dataset library from Hugging Face. This has all sorts of data like which you can use for your pre-training or for your fine-tuning, for fine-tuning your models. So I am using a common crawl data set over here, and we are using the English data set. And so whenever we are creating a data set, we always create a train and a test split. So we are using the training split of that data. And what the streaming true is doing is it tells the Hugging Face library that I want to load the data gradually, not all at once, because this data would be very huge. We don't want to load all the data at once. So we are going to load this data gradually. So what this load data set will do is it will give you an iterable, and this is the iterable which we can iterate and see what data it has given us. So we are just seeing top 5 data over here. Okay, so let's just look at the data. If you see the first data, it says beginners BBQ class taking place in Missoula. Do you want to get better at making delicious BBQ? So it is talking about a BBQ class. Then if you see the second data, it is a discussion in macOS Lion. So it is like some issue, some user is facing some issue, not enough space on disk to restore. And then the third one is, I think, great hip hop or jazz dance costume. So if you look at the data here, this data is very random. It has no structure to it, and it is very, diverse. One is for BBQ, another one is like related to some IT issue, I believe, and then the third one is related to jazz or hip hop. So this is the kind of data which is there in the pre-training phase, and the model is trained on such kind of data, which helps the model to understand the language, gain the basic skills of the language. But uh, where the model, what the model lacks is the precision in the output, and that is where fine tuning comes into picture. So now what we are going to do is we are going to take the same we are going to take a pre-trained model, and then we are going to fine tune it with a company's data set. So here we have taken a data of a company named Lamini, and the data which we have taken is mostly the FAQs of that company, and FAQ section of that company, and the internal engineering documents which are there. So we have fetched that data, and we are going to use that data for the fine tuning. So we will see those steps further. So right now, what we are doing here is uh, we are just creating the input which we are going to give to the model, and then we are going to fine tune a base model with this data. Okay, so we have fetched this data from the again the Hugging Face data set. You can also use a JSON L file. What a JSON L file is, it has JSON data, but the only difference is that every line is a JSON object of its own. That's why it is called JSON L. That's, I think, JSON lines. So you can either use a file, or you can load the data from Hugging Face, right? So we take the data, and so data is in the question and the answer format. So this is the data which we have over here. This is the question: can Lemon generate technical documentation or user manual for software projects? And this is the answer which we expect. So the data set which we have has around like 1200 or 1400 such set of data in it. Okay, so what we are going to do is, before fine tuning, we need to structure the data uh, in a way. We are going to format the data into a template so that it's easier for the model to understand what kind of data, or what kind of input it will be expecting. So the most common way of doing that is just concatenating the question and the answer, or the input and the output, and then feeding it it to the model. So here what we are doing in this block is, the data set which we have is, it can have either question and answer columns. So we are just concatenating the question and the answer column into a text. It can also have instruction and response uh, columns. So we are concatenating instruction and response in this text, similarly input and output, and we are concatenating on all that data into this text format. This is one way of doing it. There are more ways of formatting the data. One such way is to create a prompt template. So if you see the prompt template over here is, uh, we are defining this we are giving this three hashes, and then we are giving space and the question, and then this is where our question comes in, and this is where our answer comes in. Why have we given such format is, when you train the model on this data, uh, after a certain duration, the model would start expecting question after this tag, and it would generate answer after this tag. So it learns what's coming next. Okay, so we can use such templates as well, and we are going to use this template for fine tuning uh, our model. Right. So now what we have done is, we are just taking the first row of reading the first row of that data set. We are getting the first question and the first answer, and then we are just hydrating this template. So this is how our input structure would look like, right? So that is one prompt template. We would need another prompt template with just the question. this is where the data would be trained on with question and answer, and this is what you're expecting. So this would be used for your testing data, where you will just send the question, and the model would be generating the answer. So this is the template with just the question and where we are expecting the model to generate the answer. So again, uh, we are going to hydrate these templates with the data over here, okay, from the data set which we have loaded on top. We are just hydrating the templates, and this is the final data which we have, which is created over here, and we can see the first data, which is like question and answer template, which is there in a text attribute over here. Okay, so this is in the question and the answer format.
Sorry, Nishi, for interrupting you. Is it possible to share the collab link with
Yes.
us in the chat? And um, we
Okay.
have to make sure that is able to share it to anyone with the link.
Okay, I can share it right now.
All right, thank you.
Yeah, but just give me 1 second. I just need to check if there aren't any keys which I have added. Okay, I think I removed it. Yeah, I removed it. Yeah, sure. I'll share it. Yeah, yeah. Just give it a try if that works.
Yeah, it's asking for you
I
need to
think.
request access.
Sorry, which axis?
So the link for the collab, you need to provide access to everyone. So if you go back to the collab and you click the share button, um, so then you can see unrestricted
Yeah,
anyone with the link. Brilliant, thank you.
no worries.
Let me double check. Okay, now everyone should be able to get into the collab.
Okay, cool. All right. So till now, what we have done is we have just created a structure for our data. And this is the data which we are going to use for fine tuning. Right. So the next is instruction fine tuning. So what is instruction fine tuning? It is nothing but so we are going to train our base model on an base model in such a way that we are going to use this fine tuning data set and train it so that it can answer questions on the basis of the instructions which we are providing, and it would be able to answer questions on the company specific data, because we are training it on that company specific data. So whatever questions we ask about that company, it should be able to answer. So this is one type of fine tuning, and it is more relevant for the chat interface. There are other type of fine tunings as well. We'll get into that later. Okay. So here again, we are using the transformers library. We are using the transformers library, and we are using the dataset library from Hugging Face. Uh, so what we are going to do here is we have taken a data set, the alpaca data set. This data set is in the format of instruction. So it has this instruction, it has this input, output, and it has, I think, a text as well. Right. So what we are trying to achieve here is, if we give this instruction like give 3 tips for staying healthy, and let's ignore the input now. Let's ignore the input for now. If we give this instruction, we should get this output. Sorry, just give me 1 second. Yeah, yeah, sorry. So my bad. This is the data which we are going to, the lamini data set which we created, right? This we are going to use for fine tuning in the next section. This instruction fine tuning, we are using a separate data set. My bad. These are two different data sets. Here we are just trying to train a small model, where if we provide an input as an instruction to that model, it should be able to uh, give you the output in this desired format. So if we take this example, if we give this instruction, give 3 trips for staying healthy, it should give you like the answer with the 3 tips here. Okay. So we are going to do the same thing which we did in the previous step, where we are creating a prompt template. We are creating two prompt templates over here, one prompt template with input and another prompt template without input. So input is, if you want to give more context to the instruction which we are passing, then we can add more context over here. And we are going to train the model on two different templates over here. One is if it has an additional context, that data. Another one is where it doesn't have a context. So here, unfortunately, we have data which doesn't have input, but the data set will have both the kinds of data over here. I'm sorry, I cannot run the collab here at the moment because it will take some time to like run each and every step. That's why I have ran it initially, and then I'm just walking you through the input and the output. Okay. So yeah, so we are creating two templates over here, one with the input and one without the input. Okay. And then we are just creating the data over here, where uh, we are giving the input as the processed prompt. So if it doesn't have an input, it will, here we are hydrating our templates with the actual data, and this is where we are appending all the data. And if you see this step, this is where this is how our data looks like. This is the data which we are going to use to train the model. So we have clearly structured this data and as input and output. So this is the input which would be given to the model, and this is the outputs which we are expecting from the model, right? We can create our own data sets, and we can write it to the JSON lines file, and we can upload these files onto Hugging Face as well. But I'm just ignoring this step for now. Okay. So yeah, so now again, what we are going to do is we are going to see how a base model, the Llama 2 base model, which is the pre-trained model, how that responds, and how does an instruction tune model responds to the same prompt. Okay, so if I give this prompt to the pre-trained model here, uh, uh, the same prompt which we gave previously, it says that I have, it's the same output which we saw, right? And then we have used this data set which had like 1400 or 1500 rows. We trained it. Sorry. Yeah. So we trained that, and we are going to look at the training process here. But after training, it gives you a structured output over here. So this is what instruction fine tuning is. And now let's get into how actually the fine tuning process works, where we are preparing the data, where we are training a model, and then we evaluate the model, right? So data preparation, there are 4 things to consider. First is we need to collect the instruction response pairs, like we collected the data over here. We need to collect data for the specific task. So here what we are trying to do is the lamini data set, which we saw in the previous uh, the section before this. We are going to use that lamini data set, and we are going to concatenate the question and answer pair, that also we have seen. Once we have that structured data, we are going to tokenize that data, and then we are going to create a split of train and test on that, and then use that to train the data. So in this section we are going to mainly focus on the tokenization bit, uh, the tokenization bit in the data preprocessing step. Right. So here again, we are using the datasets module, and from the datasets library from the Hugging Face. We are using the transformers library from Hugging Face, and we are using this auto tokenizer class from this transformers library. What this auto tokenizer class does is it will find the best tokenizer which you should use for that particular model. So here we are using a very small model. We are using an open AI model from this Eleuther AI, which is trained on 70 million parameters. 70 million is a small model. Because we want to run this on CPU, we are going with such a small model. Okay, so first let's just take an example of how this tokenization works, and then we are going to run these steps on our Lamini dataset. So I think in the last session we saw this text, "Hi, how are you?" We are going to use the tokenizer from this auto tokenizer class. We are going to use this tokenizer, which will convert this text uh, into the vector format. So this is our encoded text, right? And we are going to use the decode and see if it decodes it back into the same text here, right? Now let's say if we have a list of inputs. "Hi, how are you?" "I'm good." Yes, we have these three inputs which we are feeding the model. Then when we tokenize this input, we will have three vectors over here. So if you see, this is "Hi, how are you?" So if you see the tokenization, how the tokenization is happening over here is "Hi" is one token, then comma, "How are you?" and then question mark. So that's how the tokenization has happened over here. And what so the problem here is that the input vector are different, are of different sizes over here. And when we are feeding an input to a model, we want to ensure that each input is of the same length. So that's where padding comes into picture. So if we see, the longest input over here is let's say six characters here. So we would want to append uh, six. We would want to append these empty tokens at the end of each input where the length is less than six. So what we are doing here is there is something called as padding tokens. So we are assigning the padding tokens as end of sentence token. End of sentence token here is zero. So it is taking that as the padding, and then we are basically adding padding over here to all the inputs through this text. So when we are calling our tokenizer function, and if we pass padding as true, it will assign the end of sentence, this 000, to all the inputs which are shorter uh, than the defined. We can also define our input, we'll see in future. We can also define the maximum length of the input token, but here we are just taking the longest input which we have, right? And yeah, so here if you see, we are defining the max length as 3. So here we are defining, if we want the input size to be only 3 characters, then we would want to truncate our input. So that's where we are defining truncation as true. So if you see, what it has done is it has truncated the right hand side of the data from all the three inputs. Now sometimes when we are giving an input to a model, we would mm, our main content can be the content which would make more sense can be there on the right hand side of data. So we would want to truncate the left side of the data while processing, so we can specify the truncation side as well. So that's what we are doing here, and this is basically taking the right three characters from the right, and this is so we can just call the tokenizer function, and we can pass truncation true and padding true all in, like we can pass all the arguments in that function, and then this will give us the final output. Hope this makes sense of how the padding and truncation works over here. Okay, now we are coming back to our Lamini docs JSON file. So we are taking that Lamini docs JSON file. All the data is there over here. We are creating the structure which we discussed previously. We are creating a prompt template with question and answer, and finally, this is the data set. This is the structure of the data there. Now we are going to tokenize this data, right? So here we are going to create the tokenized input. We are going to pass our text. So let's just take an example of the first line of our data set, and so we are just passing the first input as text over here. Here the return type is numpy, because we are running it on CPU. We are using the return tensors as numpy. You can use PyTorch if you're working with GPUs over here. Okay, and then we want to add padding if the inputs are shorter. Okay, so that's the first input. That's how it looks like. Now we are going to do that for the entire data set. So what we are doing over here is we are figuring out what is the maximum length of data in our data set, and whatever is minimum, if like the maximum length of an input in our data set, or 2048, whichever is minimum, we are just taking that and then using that as our max length, and then the rest of the data would be truncated. So this is our tokenized input, and you can see a sample example over here. This is how it looks like, right? So whatever we have discussed till now, we have just created a tokenized function, and we have added all these steps over here so that we can use this tokenized function when we are training our data, training our model, right? So okay, now what we are going to do is, yeah. So once we have the tokenized input, right, we are going to create our data set. The data set which had question and answer, we'll add our tokenized input also to that. And so this input IDs would basically be the tokenized IDs. And then it also attaches the attention mask. So attention mask is basically done during the embedding process. So we would basically attach the attention mask also as part of this process over here, right? Now whenever we are defining a data set, we would always define a train and a test split. So that's what we are doing over here. We are this will give you a train and a test split, and so what we are saying over here is we want the test split to be 10%. So 10% of the data would go into testing, and we want random we are just going to shuffle the data, and random 10% will go into our testing data set. And this is seed is just for you know So next time if someone is using, if next time someone wants to create the same kind of data set, this ensures that the same random data has been moved to the test split. So this is where now we have our data set. If you see the data, this is our data which is created, which has question, answer, which has input token, it has attention mask, and we have added a labels column as well, which is basically just the input ID. Right. Now we are going to train our model. So basically, training a model can happen in just three steps. There are a lot of functions out there, like there are training functions which is there for every model, and you can just call that function and train the data. So if we talk about the same Eleuther AI model with 410 million parameters, which is trained on 410 million parameters, we take this model, we load this model with this data set, and then we train it. This is like the simplest way of training the data, but we'll go deep into these steps of training in this collab, just to have a better understanding of it. So before all these functions, this was the normal way of training a model. So for epoch and range, epoch is like the number of iterations you are doing on that model. Okay, so for that iterations, this code will run. Then batch is a set of data. So we are taking one set of data, and uh, we are calculating the output on that data. So this output step will run for each data points in this batch, and it will generate the output. And then for each output, we calculate the loss. So how we calculate the loss is we actually we see how far the predicted output from the model, the predicted output from the model, how far is that output from the actual output which we are expecting. And then we use back propagation, and we use this optimizer dot step, which basically adjusts the weights, right? But now there are functions which you can directly use, and we'll get into that now. Okay, so there are a lot of code which is like duplicated, which is there from the previous section. Here we are just creating the tokenizer, we are just creating the tokens over here, so I'm just going to skip that. But this is what we saw in the previous section. Okay, the base model. So we are taking we saw that we have defined the base model on top, so we are using the Eleuther AI base model. Okay. Now we are now calculating the device count. So this is just a PyTorch function which would check whether you have GPUs available or not. If you have GPU available, it would run your model on a GPU. Otherwise, it will select the device as CPU. So we are running this entire collab on CPU. So it will load your base model onto the CPU over here. This is just loading your base model onto the CPU. And then we define our inference function. So this inference function is basically generating the output from that model. So what are we passing to this function? We are passing a text, which is our prompt basically. We are passing the model over here. We are passing the tokenizer which we are using. Then what is the maximum input token which our model can accept, and what is the maximum output token which it would generate. So those are the values which we are defining over here. And so again, we are this is the input IDs. This is how we are going to generate the input IDs. We are using the PyTorch tensor over here. The truncation is true, and we have defined the max length over here. Then we are generating the output in this method. And here, if you see, we are moving our input IDs also to the device. We need to do that for better performance of our model. Then once we get the output, we are just decoding that using our tokenizer, and this is the generated text answer. What we are doing over here is we are just truncating the prompt, because the way we trained it was we had a question and an answer template, and so the question bit has to be removed. Okay. So this is just the function which we have defined over here, and now we are going to use this function. So this is our data set, right? The data set which we created, and this is the question. We are just picking the first question from our data set, and then we are just running an inference on that. So right now the model is not trained, it is just a base model. So this is what the output we get. And our question is, can Lemon generate technical documentation or user manuals for software project? And you see the output doesn't make sense at all. Now, what we are going to do is we are going to actually train the model. So we have defined here max step as 3. That means it will do 3 iterations, okay, which is very small. I know nothing will happen in 3 iterations, but just for the sake of it, we'll see what happens after 3 iterations and how our model behaves. So we will define our trained model name over here, and we define the output directory where the trained model should be saved. Okay. Now coming at the arguments. So when we are training a model, we need to pass few arguments. These are known as hyperparameters, and this this help with the training process of the model. So you can play around with these arguments yourself. I'm not going to go into each and every argument here, but just let's go through the main ones. So we define the learning rate over here. This is the usual learning rate which we provide for the models. Then train epochs. This is like number of training epochs. So we are just defining it as 1. And then we are going to define the evaluation strategy, which is steps. So what this will do is after every 3 step, it will evaluate the model. So that's what this is doing. And then we also define the optimizer. Yeah. So we have defined the optimizer as add a factor. So what this will do is this will adjust the weights automatically uh, as per the loss, right? Now, this function is just calculating the memory footprint of the base model. This is the floating point operation. This basically just calculates the memory footprint. And if you see for a small model also, if you see the memory footprint over here, is it's like 300 MBs, which is quite a lot. So now let's train the model. So we are going to use the trainer function to train our model. And to this trainer function, we are going to pass our base model. We are going to pass our memory, the floating point operations, and then the total steps, how many iterations we are doing. We are going to pass the training arguments, and then our training data set and our evaluation data set. So when we run this function, this basically logs the loss and the learning rate. So if you see, since we have just run like 3 iterations, the loss is not going down. But if we run it for like 1,000 or 2,000 uh, iterations, you will see the loss value going down, right? And then we save this to the directory which we have defined. Now we are using the saved model, so which has been trained for 3 iterations. We are just using that model, and we are going to generate a text on that model and see how it performs, right? So this is just, we are moving this model again to the device, and then again we are picking up the first question. And if you see over here, it has, like, it still doesn't make sense. It has, I have a question about Lemon specific software development. It is just repeating itself, and it still doesn't make sense, which is true because we have just trained it on just 3 steps. But now we are going to train it on the entire data set which we have created, and we are going to train it twice on that particular data set, and then we will see the output. So that's what I have done here. And if you see the output, so the same process which we did up, right? We are just going to change. We are just going to provide the entire data set for training to that to our trainerize function, right? And so this is the output which we get, which is still decent. So and I can generate technical documentation or user manuals for software projects. This can be achieved by providing a prompt for specific technical questions. So even if you see the output generated from this f- uh, from the model which we have trained for, which would have been trained on around 2000 rows of data, uh, it is generating a decent output, but again it is repeating itself if you see over here. So this can be achieved by providing a prompt for a specific technical question, by providing a, so you can see it is still blabbering. So if we add more data and if we train it with more data, it will generate a better result. But this was just to understand how the training process works. Okay. Now let's talk about moderation. So I think in the last session we were talking about hallucination, and we were talking about why I can't just model say I can't do this, or instead of just giving a random output, why can't just model say that I don't know or I cannot do this. So for that also we can, like, we have to train the model to respond in that way. So for this company data set, we have curated a set of questions which would give answer like, let's keep the discussion relevant to lemon. So why do we shiver when we are cold? Let's keep the discussion relevant to lemon. So if you train the model on data sets where, where the context is not relevant to our to the company, this is the data where the context is not relevant to the company's data set, you train the model on that kind of data, and then it will respond uh, saying that it doesn't know, or let's keep the discussion in this scenario, let's keep the discussion relevant to lemon. So we train this on this data set, and if you see here, if we ask this question, why do you think of Mars, and I think this is because it is a smaller model, I think it's not giving the right answer. Yeah, if you train the data on on a larger model, it will give you this answer, right? And then we fine tune. Okay, this is just fine tuning it in 3 steps, which we saw at the start of the training. So this is basically how the training happens during a fine tuning process. Okay, now let's move to evaluation. I am not getting into this. So this step is just like we have used this train function, and then on we are just using this evaluate function, which is provided by the base model runner, and then we just evaluate the model. But we'll get into the detailed steps of evaluation over here. I'm just ignoring this for now. So just I'll just have water. Just give me a minute. Yeah. So let's get into the evaluation. So now that we have trained our model on that fine-tuned data set, let's see how our model is working, right? So again, you can do the evaluation in like one single step. If you see over here, we can just call the module dot evaluate, and then it will give you the output. But I just want to go a bit deep into how the evaluation of an LLM works, right? So what we what we are going to do here is, I have just created a basic evaluation function, and what this evaluation is doing is, it is just doing a string comparison of the output generated from our fine-tuned model, and the output which we are expecting, and we are running this function on the output which is generated by our model. So this is just the inference function which we saw in the previous section. Yeah. So here is where we are going to run our model, right? And okay, I have not run these steps, but okay, I can just quickly go through what happens over here. So let's say we have I'll just take example from here on the above. If I have any, yeah, so if we ask this question, what are the types of documents available? If this is the question which we are asking, we are expecting this response, right? And if we don't get this response, like if there is a minor text change, it would this function would give a result as false. This is like a very very basic way of evaluating your model. But there are other ways of evaluation out there where you can do a vector comparison, and if the vectors are similar, I mean, it will give you how well your model is performing. Uh, and just give me 1 second. I think I did have. Yes. Okay. Yeah. Okay, cool. Yeah. Sorry, I was looking at the wrong collab over there. So yeah, this is the predicted answer and the target answer. So if you see, when we run the evaluation, this is the predicted answers and this is the target answer. And then on this, if I run the function which I've defined, where we are just evaluating on the basis of the string comparison on the both the test, it will give you a false answer. But that is, I mean, we can define our own functions for evaluation, and then we can, evaluate the models that way. Uh, I think that is it for Colab. I'll go back to the slides and we'll talk a bit more about evaluation. Let me just check if, okay, there aren't any questions. Yeah. Okay. So I'll get into the evaluation bit. I just wanted to cover these slides first. So when to fine tune? If you look at this slide, so if you have huge amount of data and you have the compute power and you can afford to train a data from scratch, then you can, I mean, obviously take a base model and do pre-training and then fine tune it for a specific task. But if you don't have those capabilities, then you can always take a base model, and then you can specify the data related to your task or related to your domain, and then fine tune that particular base model with that data set. uh, we will get into retrieval augmented in the next session. We are just focusing on fine tuning here. So what are the benefits of fine tuning? Fine tuning helps stop hallucination. And how does it help stop hallucination is like the more clear instructions you provide while fine tuning, the more context you provide during fine tuning, the better your model will respond. So it all depends on the data, the kind of data which you have gathered, and the kind of data which you are using to train your model in during the fine tuning phase. And then it increases consistency because you're training your model on a very specific data set. It reduces unwanted info, right? And then it is low cost per request. It increases transparency, and it gives you control of what kind of output you want to generate. Right. Then coming to types of fine tuning, in the collab today we saw instruction fine tuning, which was a very basic fine tuning. And in that fine tuning, when we were training the model, all the parameters were being modified. So in instruction fine tuning, all the parameters are modified, but there are more advanced fine tuning techniques out there where you don't have to modify the parameters of all the layers of the model, which is known as parameter efficient fine tuning. Uh, I am not going in deep into this because this would need some advanced machine learning concepts, so I'm not getting too deep into this one. There is another type of fine tuning which is known as low risk adaptation. What happens in low risk adaptation is it freezes the original model, so it does not modify the attributes of the original model, but you can add new layers. Train those you can train the model on those new layers, and then you can then attach that to your pre-training model layers, and then get an output. So that is another efficient way of fine tuning your model. And usually you can do this, like you can also do one level of fine tuning and then do a low risk adaptation on top of it. Right. So evaluation is very difficult. To be honest, evaluating an LLM is very difficult because there are matrices out there, but those matrices are are very generic. Like there is one matrix which is ARC, which is very well known, and it evaluates large language models on the science knowledge. Then there are matrices which test LLM on common sense and other various domains. But those matrices will not necessarily fit your case because you want to evaluate your model on your company specific data set, or whatever task you have defined, right? So those generic matrices are not always helpful. So the best way to evaluate your large language model is human evaluation. So you have a good test data with you, and then use that test data to evaluate your model. And you need someone to evaluate how that model is doing using that test data, right? There are elo rankings as well, which is coming up nowadays, which is basically ranking again, which is ranking the models on the basis of certain matrices. But it, it would fit you if your use cases are defined in those matrices, right? So then moving on, approaching fine tuning. So I'm just going to wrap up the session with what approach you should take while fine tuning. So the first and foremost thing is figure out the task which the pre-trained model is not good at, or which the task which you want to fine tune the model, or which the task which you want the model to perform really well. So figure out your task, then collect the data related to the tasks input and output. And if you don't have enough data, generate the data. You can take more another model's help to generate the data as well, right? And then start with fine tuning a smaller model, and make sure when you're gathering the data is diverse enough to avoid bias in the output. Then evaluate your LLM on what's going well versus what's not going well. If your data needs more improvement, then get your model needs more improvement, then collect more data to improvise. And then increase task complexity, and if you can increase the model size for performance, because the smaller models doesn't tend to perform that well. So I think that is it for today's session, and I think we're right on time. So I would open up for questions. Um, if you have any questions, you can just post on the chat. Uh, okay, if you are so for running the collab, I'll just mention few steps for running the collab. Uh, you would need to create an account on Lamini website, and then you will have to get the key from the Lamini, and you have to add that key to the LM engine. Let me, sorry, I'll just share my screen and I'll just go through that once again. So, okay, create an account on the Lamini website, and you can get the key, and you can use that key over here. It gives you like 200 credits, but I mean, the whole collab will not burn, uh, it would hardly burn any credit, right? So that is one thing which you would want to do. And if you are facing any issues while running the collab, just message me and I can help you out. You can define a configuration file, and then you can keep your conf. So, okay, let me share my screen again. So there's a question like, if you want to share the collab, how to hide my key. So you can go here, you can create a config file. You can create a config file here in the folder, and you can place your key over here. Right. Okay. Then there's another question: can we do instruction fine tuning? All LLMs, or some LLMs are only good at some lateral processing tasks like summarization and NER, etc. So it depends on, instruction fine tuning is basically generation of text, right? So if you're looking for instruction fine tuning, I would suggest to go for models like GPT, which are like autoregressive models, so that would perform well. Auto encoding models might not perform well for your generation tasks. Hope that answers the question. All right. Is there any other question?
I think we're good. I don't know if um, Faye has something on the Discord side. No, I think we're okay. Yeah. I think we're good. We are going. Okay, Faye is saying that everything is okay. So, yeah, thank you everyone for joining us today. Thank you, Nishi, again for this amazing session. I loved it. It was
Thank
really,
you.
really nice. We will be posting the video on the YouTube channel along the slides. So, if you can please share them
Yeah,
with
yeah. I'll
me.
share the slide, and I'll share the collab link also in the slide.
Brilliant, amazing.
Cool.
And yeah, it will be posted on the YouTube channel tonight. So, well, thank you everyone for joining. I hope that all of you have a great weekend and see you next week.
See you next week.
Thank
Bye.
you, Nishi. Bye bye.